Now we're recording. So we'll start over here, and we're starting with the cell. Inevitably, uh, syllabus stuff. See if I can go through that. I don't want to spend any time on that. Advanced lab, advanced lecture. Here we are. For those who didn't have me before, we in the lecture it's basically exam related stuff. There'll probably be four exams. Again, there'll be objective exams. This I prefer to do that. Most of you are going to go into fields where you require some type of licensure or certification, at least, and all and the major component of those, if not the only component, is objective style exams, Scantron, the usual stuff, yeah, study guides, and you've seen this drill before. So most of the material on there, there's not a whole lot new. Lab wise, we'll address in the lab. Like I said, we're not going to be spending a ton of time with regard to the lab because there is a presentation in the lab which I'd like to do with this class, and that comes at the end. So that's sort of alternative to a test grade. For those have not been here, this is the text that we used. Um, there is a mastering site. If you, depending on how you get your book, for some of you may have used it or not, I'll have to make sure I send you the log on or the site that you have to log on to if anybody's using it. I don't do homework through that. That's about it. I don't know if there's anything. Oh, I should have erased that because there's no virtual rotation. It was an old one of these that are there. But basically, this is the important part. So, I mean, I don't see any need for students who've been here for 3.5 years or more, to go over this stuff again, the mechanics and all that stuff. It was interesting at the convocation, which is of course sort of like our faculty meeting we have at the start of every term, and they usually, the state of the school and all that type. It's a whole big thing on cheating, mostly because of all the online stuff. And I'm not, to me, I told them it doesn't really concern me. But I made the point to the other class, and I think I should make it to you. For anybody, if you're going into a field with licensure, these days, all these exams are done in environments where you can't possibly cheat. You go through a metal detector, you're working on a computer, you're lucky if you have a paper and pencil and they take the paper away from you at the end. So, I mean, I keep saying it, students who cheat themselves because, you spend a ton of money on what you're doing. If you can't get a license in your field, then it's a waste. You're better off. Look, you could be my kid who's got a high school education and has a commercial driver's license and makes a bunch of money. So take it to heart. I'm not. There's nothing in this that would ever have been construed as an accusation. I happen to. This my tongue. I'm going to punish for saying this. I love this class because I think you're wonderful people. Oh, no. You're not included. You're new.
I feel like you'll like me.
You're from Plum?
Yeah.
Yes, I looked that up. It's okay. I've had some bad luck with Plum students.
What does that mean? Do we have beef?
What?
Are you trying to start beef on the first day?
Yeah.
Yeah.
I'm just evil. It's all right. It's because whenever I haven't seen a student before, nowadays you can check up and look where they went to school and all that stuff.
You stalked me before.
Yeah, exactly. Cyber stalking.
I respect it.
As you should, honestly. I would do the same thing.
Yeah. You gotta get. Hey, I'm a cyber sleuth.
Cyber sleuth. I've seen you like every day.
Yeah, I know. That's. I don't even want to be here. And to that end, I'm going to try to do a few more virtual Fridays. Thank you.
Oh, yeah.
Yes. Bro, this is awesome.
I'm getting old.
I love
Or-
you.
I'm still trying to convince my wife to go away, but with her mom, it's we're still in that same boat. She's still spending most of the time with her. So that's everything that I have to tell you of any. Typically, the exams, I think, we certainly will do cell and muscle phys is hard. Muscle and nerve phys, the first after the cell physiology, it gets fairly intense. And so I'm sure I'll be sending some supplementary lecture material that I record for you to listen to. This stuff is the anatomy is more memorization. I think the physiology is more understanding. There's a lot, and a lot of you have had this through cell and molecular and genetic, from your other courses that are difficult, but they all come together in this, I think. So I think that's of some note. So these are just the same chapters. Anatomically, I didn't even touch on this because you have cell and molecular, and I'll just gloss over. I'm not going to sit there and review what the DNA and the RNA and all that, what's a nucleus, but we'll talk about all of that. And some of the stuff we'll just go through relatively fast. The focus points in the cell, I think, are resting membrane potential, which is vital to understand. Certainly a review of one of my favorite topics, movement across membranes. Okay, so all that endocytosis, exocytosis, diffusion, osmosis, facilitated diffusion is critical for understanding how the body works. Critical. And then certainly the cell cycle. Once again, because one of my focus points on this is what goes wrong. And when you get to be my age, what goes wrong with the cell cycle is cancer. Those are the things that really come out and jump out at you all the time. So we'll start here with it. We'll get through this. I can't imagine that we have to do. I better do B as well. B's a little bit longer. I don't know if it's A or B is longer. We'll figure it out. I think B is. Yeah, the fine print. Yeah, close. So it's the same. I mean, I do the same stuff, really, but just not in the degree of detail that we do with the entry level nursing students for A&P. And certainly and I say this all the time, the devil is in the details. It is what we are going to do to explore this that's so terribly important. And most of you would have had, I would think, this material, to some degree that's there. Yeah, made of cells, complementary structure and function, lots of different kinds of cells. In anatomy, we went over this, and really, now that it dawned on me, for you folks, I don't know how many are taking this out of sequence, or had zoology, and because we have that frequently. It is important to review, and they are on the week 1 of the Blackboard to look at tissues. Because I spent a lot of time. If like somebody like Greg had this, more than a year ago, right? Greg, I think that we had the anatomy more than a year ago. Yeah, a while back. Go back and review tissues. Stuff that we didn't go back and review bones. Take a look at those PowerPoints. They're there. Weeks 1, weeks 2 on that. Take a look with that. Come and ask me about it. Email. I respond to emails very quickly unless they're from people I don't like. Sir.
I've been meaning to ask this. So since I took comparative anatomy,
right?
Like how does that translate to this class?
I've asked Dr. Hannah that. She covers a lot of stuff, but I don't know how well it translates. I mean, you certainly have a lot of background knowledge, but it's not. I don't think it's the same. I mean, you obviously understand the way around the skeleton and bones, articulations that are there, a fair amount about the structure of the nervous system, but not. So I think you have the basic system anatomy, but it will require backtracking in each of these chapters to look at it. Is the way I would describe it. Is that answer? Okay. Lots of different cells, structure and function, what this is all about. All sorts of neat cells. When you see cells that don't have a lot of advanced development, they are cells that are easily damaged. They're usually cells that are easily replicated. But because they're easily damaged, they're very susceptible. Dr. Buxton and I, once again, are co-teaching a course in radiation biology that they asked us to do for the nuclear med folks that we did last year. And as we teach, I learn more about how fragile the cells are, not just to being exposed to radiation, but to other and potential environmental factors. So more on that. So cells like this, a skeletal muscle cell, a nerve cell, remarkably resilient with regard to being exposed to things that can damage them. They're what we call highly differentiated. I'm sure it's a concept that you're familiar with. They're so advanced. The good news is it's very hard to damage them. The bad news is you can't replace them. And when they're damaged for good. You're going to see the exception when we get to nerve cells is here. When we look at the axon, that long projection that's either sending or receiving information. That is something that has the capability of repair. And we will look at that to some extent that are there. So those are in different, and we'll get into the nuances. Many of you are taking immunology at the same time. There's going to be a certain amount of duplication between Dr. Maurer and I. I know we presented differently. I mean, I'll be asking you what you're covering to make sure that we don't duplicate it too extensively that are there. So we know about this. They have the boundary, and that's where the movement across membranes is so pivotal. We'll look at that very quickly. The nuances that are in the cytoplasm, it's this wonderful sol gel. You know, it's about solids and liquids. It's a wonderful idea. I'm sure, have you all seen that cell animation video from Harvard that you can see on YouTube and things like that? They show that to you?
It's like the one walking.
Yeah, walking along on the microtubules.
Yeah.
I used to play, like, the Grateful Dead had a song called Trucking years ago. Yeah, that's what it always reminded me of. They were a group way back when. No deadheads I could see here. Oh, God. Help. A stranger in a strange land. Nucleus controls. Yeah, it's a cell. It's freaking complex. There's a lot of stuff that goes on in there. And it's all interconnected. Okay? Understand. I mean, you have this elaborate passageway that you all got in Cell and Molecular, taking you through this remarkable sort of winding passageway from production, from genetic information and production of, replication of DNA and production of the various types of RNA, going through all of these passageways. And, basically the assignments, and it's something I know you have had, and I'm going to touch on it. But again, we go through this chapter relatively quickly, other than a couple of areas that are there. But really, to me, this just speaks of complexity more than anything else that are there. We deal with a lot of fluids that are similar, and that's the interesting part when we deal with osmolarity. Okay, the relationship between all the things that are dissolved, all the solutes, and the solvent itself. That's relatively fixed. So it precludes movement of vast amounts of fluid, and it's so terribly important. And that's what happened when we looked at the skin unit in anatomy and physiology, or in the anatomy portion. What was the biggest problem of the two biggest problems that are associated with burns? The destruction of those barriers, allowing fluids to leave, causing dehydration and electrolyte imbalances. The other problem being infection, because burnt tissue is very, very prone to it. Those are really those extraordinarily critical areas that are part of it. So, I mean, that's the clinical nugget that goes along with it. So the interstitial, the fluid between the tissues outside of the cell. So interstitial is part of extracellular fluid. And intracellular fluid are identical with their osmolar composition, but they are not with regard to the components. And what's that going to lead us into? that distribution of charge, the resting membrane potential that every single cell has, and whether or not we can alter that to send signals. And that is all the basis of nerve and muscle physiology. So, I mean, that's where we're saying that we're setting the framework or the groundwork for this. Yeah, different secretions, which we're aware of, and they have different compositions, and a variety of materials that hold things together. So all of those components are pivotal in understanding, I think. And here we are, intra and extracellular fluid. And the difference is we've got a membrane. And the neat thing about that membrane, it's a living membrane. What does that mean? Semi-permeable membrane. Some stuff can get through and some stuff can't, whether it's based on size, based on charge, whether it's fat soluble, whether it's water soluble, doesn't matter. That's the whole ball game. Everything is about movement across membranes. When it comes to us being able to see that, there's some very good animations that they do. Some are much better than others in this. The ones that are really where the visuals are particularly good, I will point out. So we begin to look, we all know about the phospholipid bilayer and the fluid mosaic models. The interesting part is what protrudes, the glycocalyx, the sugar shell. It's not necessarily complex, but there's a variation in all of us, with the exception, and we'll get to this when we start to look at the immunological aspects of it, that is so pivotal. It is the basis for something we will look at probably in the second third of this class, because we do a lab with regard to it. And I know you've had all the stuff before. Blood typing, blood groups, multiple alleles. That sort of oddball, that's a hybrid of non-Mendelian genetics and Mendelian genetics, positive and negative Mendelian, and the multiple alleles not being. How do they differ between my APOS and maybe your OPOS or somebody else's B-neg? The differentiation, the distinction has to do with this protruding short chains of sugars that are protruding off of proteins that are embedded in the membrane of the cell. They'll kill you. You will come to find out that when it comes to transfusions, you can get into trouble real fast. See, it's sort of the trick questions they ask the nurses. How many nurses do you need to have to give a transfusion? Everybody goes, oh, just one. No, I have two. Not because it's technically difficult. You need two people to sign off. They cross-check each other. The name ID, so security number, the chart, the identification on the bag of blood that's there, that all has to be checked by two people who have to sign off. Because if you, pardon the expression, mess it up, what I was going to say, okay. My wife's texting. That's important. But if you mess that up, you're going to kill somebody. Okay? Transfusions, when they're given the correct blood, save lives. But it's interestingly, as you will find out, your body responds to them immunologically. Because unless it's your own blood, and you can do auto transfusions. And that's done with some degree of frequency for people having total hip replacement or extensive plastic surgical techniques. You pre-donate your blood so they can use it again. You probably are familiar with that. But when you're getting somebody else's blood, your body always responds. It's a question of making the response minimal. I have had somewhere between 50 and 70 units of someone else's blood. Yet I'm still here to tell the tale. See, I used to have no wit and not be very intelligent. I got lucky with a transfusion. Thanks a lot. That's supposed to be funny. You notice I had my cough. I always worry it's gonna be the last time I'm going for a haircut. I always tell them that. figure I'm done. What?
You're morbid.
I'm not morbid.
Yeah, you are.
Hardly. I'm a positive person. Okay, so voila, all that you've all seen this. It's those short chains of carbohydrates. We know the constituents that are there. What I wanted to point out are the different types, not doing those animations. We know about the phospholipid bilayer, the whole polar, non-polar thing, how they inherently come together. The unique thing about lipids is they're not bonded together per se. They were just an association. And that to me is just so fascinating. And what it means is they have with the availability of signals, the availability to open and close. So we can have exocytosis and endocytosis. It's remarkable that something like if that was just a proteinaceous shell, a rigid shell, it would be impossible to do the kinds of activities that we see all the time. Macrophages couldn't work. They couldn't be the linchpin of our defensive system. They couldn't gobble up. I love macrophages. Big eater. That's where it gets its name. We eat things that attack us. I love that. And the different components that are there. Glycolipids on the outer membrane, cholesterol for stability. Okay, you all know about those things. The beautiful structure that it is, relatively thin. Okay, all that. And then the 6 different general categories of membrane proteins. So you have the distinction between integral proteins, which are within the membrane, and most of them are attached either on the inside or the outside, either externally or internally, by peripheral proteins. And what's the most fascinating thing about any molecule? When you attach something to the molecule, by and large, what happens to it? It changes shape. And that's really what this is all about. Signaling molecules. So you get a big, giant protein like insulin attaching to a receptor, and what does it do? It can't enter the cell, but it impacts the cell. It's just like what happened when you tried to come in before we were doing the class, right? I mean, the door's closed, you can hardly see through the window, and all of a sudden you see everybody turns to the door. So you have someone from outside of the environment impacts the inside, whether they knock on the door, whether they open the door. That's what happens with signaling molecules. Insulin attaches to a peripheral receptor or a peripheral protein. It impacts the integral protein, and on the other side of the insulin, on the interior, it changes its shape, and it sets off that wonderful pattern of G protein reactions that we're going to review again and again that are there. And what does it do? Basically, it creates a cascade or a chain reaction by way of an interesting molecule called tyrosine kinase that does a whole bunch of things, including opening up channels to let sugar go into the cell, using that sugar-based energy for fuel for cell replication. When you insulin, as opposed to growth hormone, insulin uses carbohydrate as its energy source. Growth hormone utilizes fats, as is steroid-based hormones do that. That's why anabolic steroids and growth hormone are performance-enhancing drugs, which obviously, after the break, the Steelers must have taken because they actually played like a team. That was my daughter. Dad, come with us to Buffalo. We're going to the playoffs. I said, Jets, Miami. The Jets are playing Joe Flacco. He can't throw the ball anymore. It's like 14 for 30. No one to blame, but did you see that roughing the passer penalty? Are you kidding me?
That was bad.
Oh, come on. He'd been escaping all day. No, I mean, I'm trying to get the guy on the ground, so you'll blow the damn whistle if you think I should.
Should have had it, but.
And I don't know which. It's less of it's like the fumble at the goal line. Less of an impact because they won the game. And nobody's talking about it tomorrow. So, how about our cardiac unit vis-a-vis what happened to DeMar? some talking about that. I don't know. We'll understand. It would be interesting to talk about it and what transpired. I mean, I think it's thankfully because it's working out, but it's a very good to understand, how things can be relatively fleeting. So the integral proteins versus the non that span, and the beauty, we all are familiar with that from biochem and from other classes out there, the folding of those proteins so that the fat soluble, the lipophilic, if you will, uh, elements are embedded within that, just the way that those proteins fold and change shape, and all the different things that they do. And the peripherals are there, and there's a variety of them. So here we are. So they focus on each one of these for transport, moving things in or out. The big question with a transport protein, is it a carrier protein or a channel protein? Okay, a channel protein typically implies that it's like a pore. And it's a matter of how many of those there are or if they're present at all. But most cells have some that, for lack of a better term, we would call pores, and most of the time what is able to move in and out is water fairly easily. It's not the only ones. You're going to see different kinds of channel proteins that we're going to get to shortly, called leakage channels. And they are specific to the small charged particles, the cationic particles. And that's really extraordinarily important when we deal with sodium and potassium leakage channels, because it's their activity that generates the resting membrane potential. The other channels that are more transport oriented, then the big distinction is whether or not we require energy to make them work. So if they are active transport channels, we require the input of ATP in some way, shape, or form. If they are passive transport, they're based on the shape of the molecule and it's coming into contact. Okay, you had all that, right? Old hat. Let me show you another anecdote. Those aren't great. Here's the signaling one, exposed, binding site. It could be big like insulin. It could be tiny. Doesn't matter. Okay? And I'll show you, and I'll go into that. Enzymes. So effectively the proteins, where we will see this in best illustration of it is gastrointestinal. You have what are called brush border enzymes. When you go back and take a look at microvilli, which are basically an expansion of surface area that we reviewed a little bit in anatomy, particularly in the small intestine. Again, it's good news, bad news. The good news, we replace those cells constantly. The bad news, they're very susceptible to chemical and radiation damage. Very, very susceptible. But what happens along those microvilli, each of them has a villus, and then they have, you might remember this, and they have microvilli surrounding it, increasing the surface area. Each of those microvilli are covered in brush border enzymes. And basically what they're doing is they're finalizing what you and I absorb. They're taking disaccharides and making them monosaccharides. They're taking dipeptides and tripeptides and oligopeptides and turning them into amino acids, which we absorb. Okay? So the whole lactose intolerant thing is because it's a disaccharide, it can't get in. So it stays in the gastrointestinal tract, and for some people creates a lot of problems that are there. Everybody has somebody who's lactose intolerant. This is that whole nugget about those short chains. Here they are, short chains hexoses that effectively are recognition proteins. Our immune system exists for them. It's the basis for them. When you get into the immunology component of it, what's it all about? In the first 6 months of your life, you become acquainted with yourself. Okay? So you have, at that point, your immune system begins to recognize what's supposed to be there. If it's something that is not recognized, because constantly it's the idea of rolling. White surveillance blood cells are constantly rolling over structures. If they encounter something they're familiar with, they keep on rolling. If it's something they're unfamiliar with, they adhere to it. As soon as they adhere, chemically, it causes those white cells to begin to do something typically adverse that's going to trigger inflammation. And you get an immunological reaction. How do we deal with that? It could be the Zyrtec I took this morning because I was sneezing. Or it could be the immunological. You'll get more about my history. It could be the Humira injection that I did Saturday night for my autoimmune disorder. A $3,000 shot. Which reminds me, I have to call the insurance company about that. Attachment. Short of sperm cells, which function as a unit, in mass, and short of white blood cells that basically function independently, okay, all the other cells in some way, shape, or form are attached to one another. Some are attached right next to each other, sort of like you guys. Why is that side of the room so crowded? Okay, this is an unequal distribution. Okay, versus here where no one's anywhere close to me. It must be us. Okay, everything is attached. The cells are attached to one another, and if they're loosely attached, then we have connective tissues. If they're closely attached, we typically have lining or epithelial tissues. So if we have connective tissues, the connection involves a variety of different types of, depending whether they're short or long or well organized or poorly organized, but they function as units. So when one tugs or it does an action, it impacts other actions. And pulling and tugging does things. Just like if you go to the gym and work out, that pulling and tugging is going to generate changes within. We're going to build more mitochondria, more nutrition, more muscle, whatever. And this brings the nugget about how they join specifically, particularly in closely packed cells, like lining tissues. You get the cell-to-cell joining, what they call cell adhesion molecules, and the three different types that we're very familiar with, where you have the strongest one, desmosomes. You have the ones that are tight junctions, which to me just put the word water in front of it for watertight. And then lastly, the connexons or gap junctions, so that whether it's charged particles or other kinds of signaling molecules can go from cell to cell. Pretty straightforward. Yes, but I'm thinking of watertight. My kid is still out there. I still think I haven't heard from him. In the Persian Gulf on his ship. No drama. Very welcome. Happy to that. What movie did I see? Oh, did anybody get a chance to watch that new Jack Ryan?
I'm halfway through.
Oh yeah, wait till you get to the part for the last two episodes, because that part of it's on. Yeah, I'm not going to spoil it, but you might recall my son is the captain of the destroyer. Just saying. I know, not to brag. Should I go or not? We were invited to a possibly black tie optional event.
Yeah, we gotta go.
I don't even have a black tie. It's a long story. Sugar shell, all the different things. And the beauty of sugars is we attach proteins to them, we attach others to them. They really are extraordinarily important. And then they play a pivotal role. And I'm sure you covered this in Cell and Molecular when you talked about low density and high density lipoproteins, that type of stuff. The LDLs, VLDLs, all that stuff. So I'm not going to go over that at this point. This is the idea of what happens with cancer cells. That one of the things is they change so rapidly that it's almost it's tricking your immune system. And we see this a lot. It's sort of the analogy to that is the genetic variation that we see in COVID and influenza and things like that. They're genetically altering so that when you make a vaccine, it doesn't work because they're constantly genetically, to some extent, reassorted. And there they are, tight junctions, desmosomes, and gap junctions. Won't go over the whole thing. It's about fluids. There they are. And the more, yeah, again, the closer they are, you really only have two major areas where they are particularly close physiologically: the blood-brain barrier, and in men, the blood-testicular barrier. Testicular because sperm cells being produced at puberty are viewed as non-self, and you would create problems. And then the blood-brain barrier, very, very specific and therapeutically and clinically very important, because only certain substances will have an impact on the brain. See, not every antibiotic, not every medication can have psycho or brain or neurological activity because it can't get through the barrier. And by the same token, where is it weakest? Probably right up there in the hypothalamic area. We commented on that in anatomy. And that's where we worry about, particularly in populations that are prone to things like bacterial meningitis or viral meningitis, which unfortunately were you guys, people who live in close quarters. Okay, and they go into the anatomy like this. I'm not going to, with the plaques and linker proteins, etc. And then we get into this. So probably the last topic in the 10 minutes or so, I'll try to get started with this, is the whole concept of selective permeability. I love that. I used to go crazy with this stuff. Okay. I know you guys have had it a lot, but it's just an everyday. That's why I made the comment about the distribution. Now, if I count the numbers, there's 7 on this side and there's 12 on, which we're missing people. 3, 7, 10, 12, 15, 18. There's people not here.
Should kick them out.
Off to a bad start.
Hey, that's not good.
They're ladies.
They're in trouble. Okay. I'll move on. I'm not going to get emotional with this. See, that got me all frustrated like this, but it's not an even distribution normally. But what happened is everybody sat over here for MCAT, and then you guys filled in on this side. It's just the way it worked. Okay. Showered this morning. You know what we did New Year's Eve? We gave the dog a bath. What are we doing New Year's Eve? We gave the dog a bath. That's terrible. Okay, so passive versus active transport. Passive we deal with first. Simple diffusion generally always refers to typically small particles, and almost always nonpolar particles. Classic example, what? Your lung. Oxygen, carbon dioxide. Fabulous. We looked at it anatomically. You have simple squamous epithelia on one side, on the blood vessel side, simple squamous epithelia on the alveolar side. You have a single basal lamina or base membrane between the two. Multiple particles can move in multiple directions. Oxygen goes this way, carbon dioxide goes this way. There can be other particles that will move. It's not limited. Okay, there's usually a vast amount of membrane surface area as compared to the size of the particles, so that's not an issue whatsoever. That's classic simple diffusion. Occurs almost instantaneously. What's the most important factor? Concentration gradient. Does the size of the particle play a role? Sure. Does the absolute amount of particles play a role? A little bit. If it requires passageway through channels or carriers, then those can be occupied. All right, but by and large, the single most important thing, concentration gradient. I don't know how many people were at the game yesterday, but you know the old story. When everybody's at halftime, you try to move around going in the opposite direction. If you're the one who tried to get a head start and run up and go to the bathroom and get something to eat at halftime, and everybody else is pouring out in that direction, you're going against the gradient, so it requires a lot more energy. Versus, oh, I mean, if at halftime you can just sort of let the crowd carry you. I'm getting over the bathroom. Okay. I want to get another beer. Okay. I have a feeling, knowing, seeing my daughter's picture, that perhaps she had some type of beverage. Just saying. The last time I went to the game, they didn't find all the stuff she had. Love her. Versus facilitated diffusion just means you have a carrier and the carrier changes shape. Again, could be in both. You could have particles moving simultaneously in both directions. And here's a bonus: when you move stuff in, other stuff can come along to the party. You can have what's called co-transport or symport. And just like that backwash that you get at the ocean, when the waves come in, when it rushes back out, so the force when it comes in is met by an opposite force coming out, you can have antiport. You know, like that undertow we have so famously in the Atlantic. You know, I like sit by the ocean, let your feet kind of get all sandy. Love that. My old joke is I used to have binoculars, so I could watch my kids, make sure they weren't in any trouble. And other reasons. Sure, nobody cares. Nobody thinks it's funny anymore. It's not politically correct. Stop doing it. I know. Why did you sit in here? I wouldn't. Okay. So we know about the speed things. The faster things move, small things whack into each other. That spreads them around. Nothing new about that. We're going to do some experiments. We're going to redo experiments probably did in high school. Concentration, small things move faster. Temperature moves to what's temperature? Average kinetic energy. Right? Increase the temperature, things just move faster. And the whole idea of equilibrium, differentially permeable, diffusion simple, facilitated osmosis. So what we were talking about in diffusion and facilitated diffusion is movement of solute. Well, solvent's the same thing. What's the big deal? So we're dealing with a number of, a universal solvent for us in human anatomy and physiology is water. So in general, if you have the same size package, when you have more solute, proportionally you have less water. It's like flipping the fraction, like converting the fraction. If you have 20 particles in 1 liter versus 5 particles in 1 liter, 1/20th, which is smaller proportionally than 1/5. So that means the 1/5 side has the bulk of the water. It's going in that direction. And that happens all the time. And it's so terribly important. When we lose, and it's the whole idea of whether things move in and out of cells. Our cells don't have the benefit like bacteria or plants do of having a cell wall, do they? No. So when we overhydrate excessively, potentially we could cause our cells to burst by something called plasmolysis, or if it's a red blood cell, hemolysis. Someone actually, years ago, you're probably familiar with the story. They were trying to sell it like California, not sell, it was a contest called for a WEE system, for a WII system. And the contest was how much could you drink without going to the bathroom. And whoever won, well, the lady won, but she lost because she died from being overly hydrated. It's a true story. The opposite of that is when you're dealing with something that is not hypotonic, where they were just drinking pure water, would be like having an abundance of hypertonic, like drinking exclusively seawater, which you could probably drink in small amounts, but in excessive amounts, it would pull the water out of the cells and they would shrink or shrivel, what we call crenation. And everything else, and that's why we use isotonic media, which have the same relationship of solute to solvent, the same concentration of solute to solvent as anything else. And it's based on what's dissolved in the water. Plain water doesn't work. So what in the hospital, what do we use? Normal saline. What does normal saline mean? One normal, or has the osmolar value that's equivalent to a typical body fluid. Roughly, what is it, 300 milliosmoles, or more or less about that. And because plasma is so complex with salts and sugars and other particles that are dissolved, we can only simulate it. And how do they deal with that? It's based on what are called the colligative properties of water. Familiar with that? What do they use to determine? Freezing point. So for those of you who were like at camp and you made camp ice cream, what did you do? Okay, but you had to have something that was cold, so you got rock salt and ice together, and effectively, and then you roll like one coffee can inside. The coffee used to come in, and you'd make that. We did that in a politically incorrect thing that came out of the North Hills Y, called Indian princesses. Notice it's not politically correct. Now they're probably Native American princesses. And dads and that daughter, I showed you when she was like first and second grade, we go to the Y camp and have a bonding thing. Which means the dads would drink all night and the little girls would play. And one of these dads is a judge. Just to give you an idea, we had quite a little group. Judge, one of the lead orthopedic surgeons in Pittsburgh, a judge. We had a fun time. Native American princesses. I will come back to the tonicities next time. Goodbye.